How does Gibbs free energy show available work? Imagine you have a battery that powers your phone or a chemical reaction that makes your car run. How do we know how much useful work those processes can do? That's where Gibbs free energy comes into play. It's like a special measure that tells us the maximum amount of work a system can produce when conditions stay the same. Think of it as the system's energy budget for doing useful tasks. Gibbs free energy is made up of two parts. First, there's enthalpy, which is the total heat content of a system. It includes all the energy stored inside, like chemical bonds or heat. Second, there's entropy, which measures how disorganized or random the system is. The more disordered a system, the less energy is available to do work. Temperature also matters because it affects how entropy influences the system's energy. The key formula is simple. Gibbs free energy equals enthalpy minus the product of temperature and entropy. When you see this equation, it's like a balance sheet showing how much energy is left to do work after accounting for disorder. If the change in Gibbs free energy during a process is negative, it means the system can release energy and do work. This is what we call a spontaneous process. It happens naturally without needing extra energy. On the other hand, if the change in Gibbs free energy is positive, the process needs energy input to happen. It won't occur on its own. When the change is zero, the system is at a perfect balance called equilibrium. At this point, no net work can be extracted because forward and reverse reactions cancel each other out. This concept helps us understand whether a reaction will happen spontaneously or not. It also tells us how much work we can get from it before reaching equilibrium. For example, in chemical reactions, if Gibbs free energy decreases, the reaction can produce energy that might be used to generate electricity or power machines. In biological systems, it explains how cells transfer energy to perform tasks like muscle movement or nerve signals. Gibbs free energy combines energy content and disorder into one number that shows us the system's capacity to do useful work. It's a powerful tool for predicting spontaneity, understanding how systems reach balance, and calculating the maximum work available in real-world processes. So next time you see a chemical reaction or a battery powering up, remember that Gibbs free energy is quietly revealing how much potential energy is ready to be turned into action.